Okay, did you see the universe homepage yet? It's the current version
No, I don't know where is it.
of it. There, I'll send that to you. And then there's many things wrong with this, but it's just, it's emerging. And I'm actually going to be working on it tonight, but we finally got the infrastructure for it more or less working.
Okay, it's pretty good. We need some filtering and sorting though.
Oh yeah, absolutely. Right. And that's coming. Some of it will be in JavaScript, some of it will be elsewhere. Basically, we'll have a bunch of pre-canned sortings that will be basically done in JavaScript. And then for the more elaborate stuff, it'll do a kernel API call.
Yeah.
So.
Yeah, but this is really useful already.
What's that?
Because this is very useful already.
Yeah, I agree. I mean, it's going to have a lot of nice. I don't know whether it has click to copy yet. No, it doesn't. But that's going to be click to copy, so you can easily get the thing into your session and so on. One thing. Oh yeah, let's talk about that for a second. For this, I need that limiter. I mean, I can either write it by hand. So what I'm trying to do. Okay, so let me explain what I'm doing here. I would like to run these rules a certain number of steps, right? But I want to run them until they have, let's say, I don't know, some definite number of, you know what I'm saying? Some definite number of nodes, for example, a definite number of edges. Makes sense?
Yeah.
And then so what I want to do is to get back the evolution object that knows how many it chose to do, but I would like to have a limiter. Is that easy to implement? Could you implement that quickly? Because I'd really love to do that for the run I have coming tonight. So here's so let me.
Well, it's not too hard.
Okay, but let's just agree
I
what it
see. You
should
want
do.
it tonight. Oh, let's see.
Well, let me just take a look. Let me just take a look at what I'm doing here. So. So you see what I've got here. I've got an advisory number.
I don't
here.
see your screen.
What do you mean you don't see my screen? Really?
I don't think you shared it.
Oh, I forgot to share. Sorry about that. It was not very exciting. Okay, there we go. Oh, so when I was showing you the universe thing, you weren't
Well, I
even
opened it myself.
Fair enough. Okay. Anyway, okay. So what I've got right now is, I want to get rid of this file, right? Because this file is where I'm collecting interesting universes, but I don't want to be doing that just in this file. I want to be just doing it on the site.
Yeah.
Okay. And what I've done in this file is I've put an advisory number here. Okay. And when I'm doing searches, I'm having it run until it, I'm being very conservative. I'm only running it for 5 steps or something. But what I want to do tonight is I want to run a big search looking for universes with messy size growth. Okay. If that makes sense. Do you understand what I'm saying?
Yeah. So I think there are two things that are going on here. So first, you need to have fixed number of generations, not in between generations.
That is correct.
Which is separate from the that we need to limit by number of expressions rather than events.
That is correct. Hold on. Let me just show you what I've got here for this registry. Okay, so this was my function, which right now does nothing. That is initial condition, okay, node goal, final max steps, and so on. I'm not sure what the right way to do this is.
Well, we already have an association where you can specify generation and events. So you can also specify a number of expressions there.
Okay, well, fine. So let's make the change in the documentation if we could, just so we're memorializing what we're doing there. Fair?
Sure.
Okay, and by the way, I found that the okay. The evolution object documentation is very, very incomplete. And I also would like to talk about the property names there for a minute. But let's look at this one first. By the way, I assume you are editing this file to make it so that it actually calls the correct library link thing and so on, right?
Well, no, not yet.
Okay, but you're close to doing that, is that correct?
Yes, I think so. So I talked to people who know how the internal packet server works, and they told me it's going to take a long time to actually get it approved for that. So they recommended me to just store it on GitHub for now.
Oh, for God's sake, who's got to approve it? What bureaucracy exactly approves this?
Well, I think UA needs to approve it.
Okay, fine. Well, okay, you can store it on GitHub for now, and then we'll switch it over after. Then we'll start the approval process for the main one.
Right.
Okay. Okay, so this, like generations tmin through tmax, do we believe in that, or should we just punt that one? Do you think that's worth
Well, I
having?
don't really
It's a
know
waste
how
of time?
useful it is. Say
Yeah.
again?
What? No, I agree. I'm not sure how useful it is. It's to be consistent with cellular automaton, but I'm not sure that's sensible. This DT thing, is that helpful or is that not helpful? I mean, are you going to store the data anyway? I mean, I can just imagine if the data gets very big, well.
So if they grow exponentially, it doesn't matter if I store previous steps or not.
Yeah, I know. It's the ones that bubble around, not growing exponentially.
Yeah, well, right now, the way all the code is set up, it stores everything anyway. And it will be very big refactoring to not do that.
Fine. Let me remove those. Let me just put them down in the author notes at the bottom, okay? Oh, for God's sake. I'll clean that later. Okay, are you supporting the T with braces around it to mean generation T only, or are you also not supporting that? I don't think you need to support that because it's just final state, isn't it?
Pretty much,
that's silly. Yeah, that's silly. We're just saying the thing returns a Wolfram model evolution object. Okay. Oops. Okay.
Yeah, so that's the part we need to modify.
Yeah, I know. Hold on a second. Somewhere here we need to say that it returns. Does it always return? So are we going to do this thing with a single state, a single step like this? Are we doing that?
Yes.
Okay. Okay.
I mean, it works already.
Okay. Okay. Great. It's all good. Okay. 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 I'm just reading this. Sorry. Okay. In Wolfram model rules init t ... t can be the let's see. T, okay, gives results for T complete generations. Specifies alternative completion criteria.
Oh, there's a ... there as well.
Can we use to specify alternative completion criteria? Possible elements in a sock include. Okay, so here we want to say okay, so are we going to do an up to, or how are you doing that now?
Yeah, they're up to.
They are automatically up to, or are they?
Yes, all of them.
Okay. Okay. Okay.
All right, now the generations and events. I mean,
Okay. All right. All right. All right. Gives results for T complete generations. Possible elements and okay, so what we're going to say is events and this is maximum number of events to allow.
Yeah.
Okay. Generations. You know what we should say here for t-complete generations, or for up to t-complete generations, or however many generations. Let's see. What are we going to say if it stops earlier, so to speak?
Or up to a fixed point, I guess.
Up to or less or fewer if a fixed point is reached earlier. Possible elements, maximum number of events to allow, okay. Maximum number of generations to allow. So if we give a generations count, then we guarantee to have an integer number of generations.
Yeah.
I think that's what we do. Okay, so now what we want to say is actually we could say generations max events here.
Well, we should say max generations as well.
All right, fine. You're just trying to get it personally themed. I'm sorry, I can't help these kinds of things. See, you're still not used to the shortened form. I've concluded. Okay. In any case, all right. So now we have.
I never thought of it in this way.
Oh, Okay. So let's see. We max vertices or max edges.
I mean, I actually prefer max expressions and max atoms.
We're not going to call them atoms.
And also atoms are different from nodes, because nodes means anything at level 2 and atoms means anything at any level. So we might need to have both.
Why don't we call it max elements? Is that?
What are elements? That's very confusing.
Well, it's the number of distinct symbols, right? That's what you mean. It's the number of distinctly named.
No, it's number of atoms, because least is also a symbol, but it's not counted.
I know. It's symbols in the sense we're using here. We're not calling them atoms. We haven't come up with a name, but we're not going to call them atoms. It's a mistake.
They are atoms. They answer to atom Q. That's how they are defined.
Oh, no. Come on. There are 10 to the 90th atoms in the known universe. 10 to the 80th, sorry. We're doing universe stuff. I'm sorry. It's not an atom in that sense.
Suppose we could have real atoms in the future at some point.
Yes, hopefully we will. Hopefully we will. That's kind of the idea. Okay, so let's see. What can we call this? Max. It's the
symbols. Well, that's also.
I know. That's what I wanted to call it, because that's what I've been calling it. I think, look, we can explain this. We may change this at some point in the future. Maximum number of distinct symbols.
But should it count least then?
No. distinct leaf nodes, distinct vertex names is what it comes down to, right? That's what it actually is.
Well, if you use pattern rules, it's not necessarily possible to think of it in terms of vertices.
Yes, it is. This is in the actual states, not in the rules. In the rules, I agree with you, but not in the states. All right, so let's see. Max symbols. We've got max vertices and max edges.
Well, I guess. I mean, we could have something like x goes to x plus 1, but you could just say it creates new vertex.
It does. That's what it does.
Okay.
Maximum number of hypervertices, of hypergraph vertices.
Well, there is symbols at level 2. Maybe we should say that to be completely clear.
We said vertex
And
names.
not symbols at level.
It's vertex names.
No, but I'm saying max vertices, it means a number of distinct expressions at level 2.
Okay, we can explain that in a minute. But it's going to, okay, maximum number of hypergraph edges. Okay. Oh, for God's frigging sake. What do you mean it's unsuitable for sorting? What is it talking about? What do you mean the structure of the cell is unsuitable for sorting? Why?
Yeah, you're more specific than this.
Okay. Well, that should be sorted. Okay. All right. So let's say, okay, hold on a second. If max generations is specified, if a setting is given for max generations, only complete generations. Wait a minute, what determines whether what comes out, oh, I see, updated states, that's for every event. Only complete generations are stored, right?
Are you sure about it? I think that's very weird.
Well, we don't want to store everything unless you have a convenient diff way to do it.
Wait, what do you mean? No, it stores everything and it doesn't take any more memory than just storing generations, if that's what you're talking about.
Okay, well then in that case, then states list, then we need an option.
I thought you meant it was dropping the last generation, but
the partial generation. What do you want to do? I mean, I want it to never return. For final state, I absolutely don't want a partial generate. I mean, only, we should call it final update or something. You know, it's states list, but final update if it's a partial generation, okay? Do you get what I'm saying?
Yeah, maybe.
Well, we have to do something like that.
Yeah, that's actually not a bad way to do it.
Okay, fine.
I mean, we should have the way to return the final, well, whatever you call it.
I know. Final update.
Okay. It's strange though to call them update, because update to me sounds like a diff, not as a state.
Okay, hold on. Hold on. Okay, hold on. Let's first of all, maybe we want in this association complete generation arrow true or false. Do you get what I'm saying? That is, throw away things. I mean, do we want that or do we not care? I think we don't care, actually. Okay, hold on. Let's go down this. The list of states from each complete generation. Right?
Right.
Do you have state graphs list or not?
No, I don't.
I don't think it's that important. I haven't really needed it.
Okay.
I propose to get rid of it.
It would be useful to have state plot list or something like that.
Yes. Well, it's more useful if you have, it's really more useful. Look, I've also got that thing that does differences, which is quite interesting. But the problem is that those things, all of those require you to be able to not have all the values of t, because that'll be a mess in most cases. I think we should have the plots be separate. I think we should just plot. I've been perfectly happy. I've been doing that all along, just plotting separately. You get what I'm saying?
Okay.
Okay, so final state. The final state, paren last complete generation.
Right.
Okay, I would like some kind of states count list or state summary, which gives symbols, vertices, edges. That's what I'm saying?
Yeah.
State summaries list.
Yeah, we can have that.
Which order are we going to do it? Symbols, vertices, edges?
Let's see. Well, symbols and values most of the time would be the same.
Okay, but then let's just have vertices and edges.
Should we produce a list of associations to make it clear with this? I think if it's called summaries, it needs to produce association. Otherwise, nobody will have any idea what it is.
Okay, so it can say vertex count, edge count.
Yeah.
Okay.
Well, the same as property names, just without final.
What do you mean? What
Well,
property
we will
names?
presumably need to rename properties to also have vertex count and edge count. Except they would be Well, yeah, in the evolution object, there will be properties that has exactly the same name
Okay.
as
All right. Okay. So
elements
hold
in
on a
that
second.
association.
Well, where would it be? Where would that be? Is it called?
So vertex count is right now
Well, it would be
atoms count.
vertices count. What does total mean?
Vertices. Total means across all generations, you know,
I don't care about
union
that.
across all generations.
Okay, let's write down what these are. Okay. All right, so there's the states list. You know what, we can copy some of these, right? Actually, we'll be able to copy everything. So
well, obviously, this thing should be there as well.
yeah, okay, all right. So then why
The
don't we
only
just have?
difference is that in the evolution object we can have what's this? We can have arguments for them.
Oh, so could we here if we really wanted to?
Well, that would require some refactoring of how they're specified.
Okay, well,
But
look
the
here.
evolution object
Here.
is already done.
Okay, well, fine, but let's, okay. The next thing that's really important is the causal graph. Are we going to be able to get the evolution causal graph as well? No, does that make sense? The evolution causal graph for this? I think it does.
Well, not a lot of sense.
What's that?
Because it was just insert single state vertices between every. I mean, it's events is a path graph in this case.
Okay,
It was
all
just
right, fine.
insert nodes in
All right,
there.
okay, so let's write down causal graph here next. Well, actually, I'm gonna write down states list. Okay, so vertex counts, vertex count list, and then edge count list. You know what? We don't need the summaries list. We can just put it, if we really want it, we put a list of properties there. Okay?
Yeah. Actually, you probably can do it already. Let me check. Yeah, you can already ask for list of properties.
Okay. All right, so let's get rid of this. Okay, now what do you have along this line of this matches list and so on?
Well, nothing so far.
Okay, but do you have events count and so on? Oh,
yes.
Okay, so in this list, we're going to have some additional things like generations count and events count, which make no sense here, do they?
Well, of course they make sense. Because you can specify only generations and ask for events or vice versa.
Okay, fine. Well, how would you ask for generations count? Wait a minute. Okay, so here we would say events count list. The number of events.
By a given generation?
No, I would say no.
The
number of events between successive generations.
I see. Yeah, between.
Okay. All right. now we get into the question of I guess here, like final state, to get the number of events to the final state, it's the sum of it's the total of the events count list, right? That's right. That's fine. That makes perfect sense. Okay, now next issue is okay. These things with the individual updates. Okay, you've got updated states list here. What does that? So what we want is the list. What are we trying to get? We're trying to get the state after. It's called the. We could say event. What the heck did this just do? I would propose to call that events states. Something like that, all events states list. The list of states obtained after each successive event.
Yeah.
Okay. Now, what do we not have? The list of updates done. What is that? That's the list of events, right?
No, it's not.
How do we get the list of events? And what's this? The list of matches from each generation.
Yeah,
that's the thing that I was
done.
plotting.
That's a set cases.
Okay, but I just did that for, that's the difference between, that's the changes from one generation to the next.
No, it's matches, including the ones that you never used at each generation.
Oh, I see.
It goes into multi-way stuff.
All right, okay, well, so this is a beyond causal graph then. The list of all matches from each.
Should probably say at each generation.
Okay. List of indices of the rules used for each update. We want that, don't we?
I think so.
Which rule got used, right? So that comes above this. So that's all events states list. So then what we want here, don't we want a specification of the event? Just like, I mean, that's exactly what we're giving in the multi-way system case. We have an event representation. You see what I'm saying?
I mean, I guess you could.
Seems useful
Actually,
to me.
we could even have boxes for it so that it looks nice.
Well, I'm just saying, well, yeah, we could do that, but all events list, the list of So what's the difference here? The list of all.
But in specification will obviously be different because it wouldn't be returning the entire states at each event.
What are you saying? So this is just the list of all events that occurred between each generation, right?
What do you mean? Why generation? It will just return in a single list all the events from start to finish.
How do I know which ones happened to achieve each generation? I would have thought what
Well, I
I
mean,
need
you
is...
know the counts, but...
No, but look, the list of all events during the evolution. Okay, now the other thing we want is something which... Okay, this is badly named, all events states list, because that could be the events interspersed with states, interspersed with complete generation states. Am I making sense?
A bit.
You know what? We don't need all here. States.
Yeah, we don't need all.
Now for this one,
Maybe it should just be all states list.
I think we've called, no, that's a all states list. Isn't that a name in multi-way system? What does it mean in multi-way system?
It means the same, doesn't it?
All, no, that's different. All states generated.
Oh, I see. It will be the same, but with nested lists in it.
You know what? You know what? This should be broken down by generation, and then we'll have exactly the same thing. Or a very directly analogous thing. No, it isn't really. What about each event states list? At least we'll know what that means.
Okay.
And presumably each event states list, why not include the events that generated each of those? And then we could put events list. I personally think events
Sure. I
list
think it makes it more confusing.
Which?
I mean, if it's called states list, it shouldn't include events in it.
No, but I think it should include both events and states. Look, I think this should be events list, and I think that this should be broken down into sublists for each generation. No harm in doing that. You can flatten it if you don't like it. What's going to happen when we have these random orders? There's still going to be a notion of a generation, right?
Well, yes, except there might be weird in the sense that there might only be one event between generation.
So what? Then let's see that. I mean, so I think the list of all events.
Actually, that would be very weird because order of events would not be consistent. Okay, that's actually a big problem. So if we write events in order, they would not always increase generation number because you might have generation, 1, 2, 3, 4, and then 1 again.
Why?
Well, because it could replace one place in the set multiple times, and then it could jump to another place at which it's just generation 1 still.
But we need to be able to see that in a non-generational way.
What do you mean?
Well, I mean, we need to be able to see the fact that, okay, look, you're saying, I'm saying these space-like hypersurfaces, okay, are what am I saying here? Okay. My point is, we need to be able to see different choices of space-like hypersurfaces, right? And that means that your generation mechanism is just one such mechanism, right? So we need something, you're saying, just do the events in any order. I'm saying I want to slice it every so often and see the results every so often from those events lists. You get what I'm saying? From those states at, a state was generated.
I see what you're saying, but I don't think we should be calling them generations then.
Okay, but look, we need, no, I kind of agree with you. It's just a certain number of events. Right, which means
generations means just certain number of updates from the beginning until the state. That's its generation.
Yes.
But if it's essentially time, what it is.
Well, I understand that, but what we're saying is, imagine different choices of hypersurfaces, right? Those
yes, in which case I think we should call it time instead of generation.
No, absolutely not. Just like we're not going to call it atoms. No. I mean, look, okay, look. Let's just see, what do we want to do in the random update case? How do we want that to work? And by the way,
random events at random.
Okay, look. Node update function, which should be called event selection function, probably. Least recent.
No, it's not a selection function. It's an ordering function.
Okay, but then what are those? You get what I'm saying? What are those things? Another one of these is, random, right? Oh, for God's sake. Right, those are the cases that we know of so far.
Node update function is really confusing name.
Well, then let's change it. But I mean, okay. Let's
Isn't it just evaluation order?
Yes, it is, but no. We're not calling it evaluation. It's an update. It's not an evaluation. It's no more an evaluation than an atom is an atom, so to speak. But look,
I still don't understand why atoms are not atoms, but
okay, let's not go there.
What?
Let's not go there because
what's wrong with that
physics
evaluation?
took them first. Okay, philosophy took them even before that, but arguably we're going back.
Exactly. Yeah, and we're
going back to the philosophical meaning. But unfortunately,
we are right in both
1,000
original sense and the current sense in terms of Wolfram language.
Yes, I know, but we are ignoring 1,000 years of history, or at least a few hundred years of history. So anyway, look, let's just not prejudice that. It's just going to confuse people. Okay, so anyway, okay, let's come back to this.
Yes,
So
but
down
what's
here,
wrong with evaluation? Why is that?
I'm not sure, but let's read what we wrote before, okay?
Okay.
The states obtained after each update done on the system. So that's what we're now calling each event states list. Okay. Right? You agree? So the question here is,
maybe it's events order.
What?
Maybe it's events order.
This thing here.
Yeah.
Event choice. It should be called. Why isn't it called event selection function? Because it is the same thing. It is exactly the event selection function of multi-way system.
Oh, because it doesn't do select.
Yes, it does. It picks from a list of events which one should it actually do.
Well, select implies there's a condition and it filters events based on this condition.
I see. Okay, event ordering function. I agree. You're saying it should just be event ordering, but it could be event ordering function because we could actually have a function in there that looks at the available events and decides which one to do next.
Well, that would be very hard to do. So unless we really need it.
Well, let's not, but let's name the thing event ordering function in case we can do that. Or do you want to just call it event ordering? I mean, I don't really particularly care. Okay, let's.
Oh, it's not always a function. Well, I mean, I guess you could call it a function if it's string specified.
Let's call it event. I'd like to call it event ordering function. Okay, can we please look at these other things here? Okay, so let's look down here. Okay, state graphs list. Graph layout is taken to be the same for each graph in the list. So we did have a reason to want to do these graphs because we're trying to do a dynamic graph list.
Yes, I know that will be useful, but I need to, probably I will have to rewrite Spring Electrical code for that.
All right, okay, fine. Let's go down here with that. Okay. Okay, let's look at these here. The method to use, low level or symbolic, right?
Yeah.
Okay, node naming function. Do you have that?
Yes, I think so.
I probably should call it vertex naming function.
Yeah, right now it's node naming function.
Let's call it vertex naming function. That's what we're being consistent with in other places.
Okay. Actually, that makes me wonder if it's actually names vertices or atoms. To check that.
Okay.
Yeah, which could also imply it's a bad name because I don't remember what it does.
What's the default for event ordering function?
I think it's least recent first, which guarantees it does it generation by generation. And then, I mean, it has some other rules as well. So it's not just least recent first. It then selects by permutation of expression indices and then by rule index.
Why don't we call it automatic?
So it might need to be a list, actually. Event ordering function might be a list of functions that are
Okay, well, fine. Let's call it automatic.
Okay.
Okay, so let's say here. Okay, let's go back down here. Node update function, what the heck is that? We don't even know. Include asymptotic events. I don't think we've done that yet, but we're going to do something like that.
Yeah. It's kind of weird that it's only needed for causal graph.
Tough. Well,
should it actually be an option for the causal graph instead?
Let's not do that, okay? It's okay. It can just ignore it in the other cases. But we need to be consistent about that in the multi-way system case and in this case. And I don't think we're calling it avoid, include, we're calling it include initialization events, but don't we need termination events as well?
Well, we might. Actually, it might be better to have two separate options. Or separate values.
Well, fine.
Yeah, it might have different values.
Yeah, whether include.
I mean.
Yeah, I understand. So
I don't know how they should be called, but it's like init, final, and all, and none.
Yeah. Right. Initial, final, all, and none.
Yeah.
Possible settings for include asymptotic events.
Are they really asymptotic events?
Yeah, it should just be asymptotic events.
There's nothing asymptotic about them.
What?
What is asymptotic about them? They are just, it doesn't try to extrapolate what it does infinitely in the future.
Remember the
final
S matrix. Yeah, okay, fine. Well, so what should we call it? Initial, final events?
I guess.
Boundary events. External events. Extra events.
Oh, that's interesting.
What? Look, this is in homage to the S matrix, so to speak. What would you call the initial and final events in the scattering process?
Well, in scattering process, they actually are at infinity.
Well,
which is different from here.
Okay, what should we call this?
Special events.
Like a birthday.
Well, in a sense, they're not really events, but
I know, pseudo events.
right. Yeah, actually not bad, I think.
Well, so include pseudo events could be true, false, no. I mean,
No, it
really,
should be for values.
no, I know.
Because I suspect most of the time we don't care about final event, but we care about initial one.
Yeah. Included pseudo events. Included
Just
in
pseudo events.
No, I don't think so. I think it's got to be included. Otherwise, it's included boundary events. What do you think? Boundary events? I think boundary events is better than pseudo events.
Yeah, I guess. I suppose we could have some kind of space boundary as well at some point.
Yes, we could. Good point. Good point. That's a very good point.
Yes, it should be boundary events.
Include initial, final, all, and none.
And I guess the default is none. We could just say that.
I think the default is going to include initial events, actually.
You think? So you don't think you want to see if the initial event just immediately splits into independent pieces?
You say we do or do not want to see that?
I think it is useful to see.
I think it's useful to see the initial event as well. Yeah, that's what I'm saying. So that's why I think.
No, I mean, if the initial, okay, if the initial state is such that it just has separate, completely independent pieces, I think it might be useful to see it as causal graph being disconnected.
I agree. What's your point?
Which you're going to miss if you include initial event.
I see what you're saying. Okay, fair enough. Fair enough. Fair enough. Good point. Okay. Vertex naming function goes to all, renames all vertices.
I think it should go to automatic by default, which means it keeps initial condition names the same.
That's what it says here. That's what it says here. Use any existing labels and labels new vertices with names such as VI.
Oh, yeah. Oh, yeah, okay. Yeah, that's what it does already. Actually, no, it doesn't label new vertices with VI. It labels them with numbers.
Okay. Labels new
and
vertices.
Vertex naming functions goes to none uses VI.
Okay, all right, okay. And labels new vertices with unallocated numbers. With the smallest unallocated numbers.
Yes, exactly.
Labels each new vertex with the smallest unallocated integer. Okay, let's look at the next case. Do we care about this case here? I think that's very detailed and I don't see the point of it.
Yes, I agree.
Okay, so you say vertex naming function goes to none. What does it do?
Yeah, it means use whatever module produced.
Uses
So
the
in
result.
pattern rules, it literally means it does nothing, which is where none comes from.
Okay. Uses
Well,
label.
you could say it uses VI. So, okay, there is a kind of a bug right now in which, because C++ code doesn't have any modules, it just produces VI names instead.
Okay. Well,
Which probably
okay.
should be changed, but you know, it's not that
worth it.
critical right now.
Not worth it. Uses internal symbol names for new vertices. Is that correct?
Kind of, yeah.
Okay. Okay. Now let's go down here. Updated states list, we don't. That's now irrelevant. Actually, this whole section needs to move up. Node update ordering function.
Actually, talking about slicing events list, I think we don't need to split into lists because you can actually split it any way you like.
Okay.
It's saying if you want to get any kind of slices, you can split it in any way you like.
How do you know what states correspond to that? To each slicing?
States don't correspond to that at all because to produce states, you have to apply these events in different order. Not in the order that is returned by events list.
Sorry, I spaced out for a second. Could you say that again?
So if you want to get states list, you should not use the same order that events list returns, because that would not give you consistent generations.
Why? Why isn't it just a slicing of the events list?
Well, because again, events list could be applied 4 times in one place and then apply something.
Oh, I understand. Okay, all right, fine. You're right. But there is a version.
So we might need to have separate thing, which would be events list by generation.
Yeah, I understand.
Which would be not in order, but by generation.
Right. I think that would be, that is close to evolution events list. Okay, so what that is, It's that, isn't it? And you don't need the separate states list, except this isn't this off by 1? Isn't this a different length than states list? It is.
Yes.
Okay, this thing here, events count list. Okay, this should be called generation events count list. And this should be called generation events list. And that should be the list of events between successive generations.
Yeah, makes sense.
The list of all events, and I think there should be a thing right after that. This is called events states list that gives the event and the state, the event and the state.
Sure.
Okay, state matches list. I think that's right. The list of all possible matches for states at each generation. Correct? Now, that could also be at every event.
It is a bit strange though, because it's not the list of all matches. So there could be additional matches in between generations.
Well, is this a useful thing?
Well, I think it's useful to an extent, but you should realize that you're not getting the complete list of matches if you use it. Maybe we should just have matches list, all matches list, so to just return list of matches across all generations or across all events.
Well, what would that mean? By the way, your thing, subset cases, is Tony implementing that? A version of that just does that?
Set cases? Yeah, I think so.
Subset cases, and what are the other ones?
Well, there's a subset replace and subset position.
Because that's what should be done if you just want to find out which cases match. You just take the left-hand side of the rule and you just do that.
Yeah. I mean, it would be much faster if you wanted for large step in the evolution, because C++ code already knows that.
Okay, well, how do we return that then?
Well, just lists of expressions, I guess.
No, I understand. But what do we do here to get to that?
What do you mean?
Okay, you want to
how to implement it?
No. What does the user ask for to get it? What is the property called?
Well, I think this is completely fine. It will just return slices of
Okay, the list of all possible matches
at
for
each
states in
checkpoint.
each generation. Okay, fine. All right. Do we care about
I
any?
might need to optimize it as
Okay.
well.
Do we care about any of these? List of updates done as events list. List of states for each update event. We already have that.
I'm not sure what that means.
Well, it's the.
I mean, we need just a list of. Yeah, we have events list. Okay.
Right. Updates rules list. In other words, which rules are
Well,
you?
the question is, do events include rule numbers? Or
Yes, they do.
Okay, then we don't need this.
Okay. Okay. All right. Updated states list. We can get rid of that note. Okay, so that's important. Property events list. All updating events done system. The events include versions of the rule specialized to particular explicit vertices. Make sense?
Yeah.
Okay, this thing here, state matches list.
So event, I guess, should just be event index.
No,
Okay,
no, it should follow the
or
same thing as the multi-way system. We know exactly what it is. It's the exact same thing that it is in the multi-way system.
Wait, I don't think so, because in that case, for example, it includes two lists for prefix and suffix, which we really don't need here.
No, it does not. Not for the Wolfram model case. It involves it gives the replacement and the rest of the state. That's what it includes.
Well, this one definitely shouldn't include the rest of the states, because it will just makes it unusable for large evolutions.
Okay.
It absolutely shouldn't include the entire state,
right,
because
fine.
it's not useful here.
Give specifications of all updating events done on the system. Each is given as a version of the underlying rule, specialized to particular version of the underlying rule, specialized to particular explicit vertices, right?
But it should probably also say which rule it was.
Okay. Each is given as...
I mean, there are two choices. We could either have it to just have, list of expressions to list of expressions here, and that's all. And then rule would be a separate property. Or we could have both in the list. It is either index or the rule itself.
Well, we could just have the... You want to have the index of the rule. This is what I just ripped out of the multi-way system code, right? The thing that gave the rule index.
Well, it might give the rule itself.
I mean, that's perfectly efficient at a pointer level. It's not so efficient if you have to serialize it.
Or is it? Yeah, that's actually a good point. I didn't think of that.
I think, look, okay, each is given as the original rule and a version specialized I think we should try that. I think that's a reasonable thing to do.
Should it have a head?
No, it should be a list.
Because if it has a head, we can make boxes for it.
No, let's not do that. Let's just have a list. We can have separate
Why not?
formatting code because I don't want to have formatting code intertangled with this thing. Later on, we may come through and put formatting code in all of this, but not right now. We don't want to have another box. It's a big nuisance to deal with that. If we're going to start having boxes,
Why?
the first one to do is hypergraph because it doesn't work well with the function repository. It's a mess. Let's not do it right now. This is an experimental function. It'll probably change before 12.2. Let's just do it this way because the most important
Well, I'm not
thing
saying I do it right now. I'm saying if you have a head, it's very easy to do it later. Whereas if
I
you
know,
don't have a head, you will have to introduce it later.
No. We'll introduce something later. I don't know how it's going to work. It's got to be consistent between multi-way system and all these other things. Let's please not do this, okay? Events list is not consistent. The thing is, it's complicated here. Right? At least we called it all events list in the other case. Okay. State matches list. What is this? You know what? It's only the left-hand side of the rule. Let's give it as the left-hand side of the original U, as well as a version of the left-hand side, right? Specialized to particular explicit vertices.
No, because we have multiple rules with the same left-hand sides.
Then we've got to give it the index. We probably have to give the index in the multi-way case as well.
I mean, I don't think index is that bad because the output of this is not very far from evolution object. So I don't think we might be in a situation where it's hard to recover.
Okay. State matches list. Please read.
Okay. So specification for March would be exactly the same as specification for events.
I know.
I think.
Okay.
Actually, wait a second. No, because events, we need to specify the output as well. Because it's not recoverable. Output has newly named vertices, which nobody knows what they were named.
Oh, I see. As well as the instantiated version.
So it should just be index As an input rule output.
Yeah, it's the instantiated version of the rule used, specialized to the particular vertices involved.
Yeah.
Okay. Okay, so what's state matches list?
That's the same, but without output. So just index and input, specialized.
Okay. For each of the events. No, for each event that could occur.
Okay, the first is the thing we need for the evolution object. There should just be matches list, which takes an argument, which is this event number. Then the question is how do you want to pack them into different lists? Yeah, that I suspect will be the one we will use most of the time. If you want to see what happened and what could have happened.
Well, so should we not have it here?
I mean, I don't know. I don't think it's particularly useful to know it at generations only.
No, I agree.
We might have a list after every event, but that would be an enormous list. We could also have the one we just all concatenated together, which I think is more useful than you might think, because you can essentially compare it to the events list.
All right. Okay, matches list. So that's all matches list, right?
Yes.
All possible matches.
Which would be a superset of events list, except without outputs.
During the evolution.
Also, maybe we should have something like unused matches list, or this thing that returns, both events and matches.
Yeah. Well, let's do that. The list of all possible matches during the evolution. Okay. So let's say all matches list gives a list of possible matches, gives for each event in events list a list of possible matches that could have occurred, possible alternate could have occurred at that point, with the actual event being first on the list. Not reasonable?
What do you mean at that point?
At that event, when that event occurs, what other matches could have occurred?
But that would be enormous.
What do you want it to do?
Because the list of matches is essentially the same length as the events list.
Right. So what do you want this to do? What do you want this to do?
I think it should. Well, all matches list should just return all matches.
When?
That's all.
All matches when?
Across all time.
Okay, what do you think the text should say?
Returns list of all possible matches that could have occurred during the evolution.
Possible matches. All possible matches that could have occurred during the evolution.
Yeah. I mean, it could return the actual event number at which this match.
No, many of them were not used.
Applied, but
okay, because the list that could have occurred during the evolution.
Well, what might be useful to know is is a kind of a range during which this much could
This is
have
getting
been
way
used.
too complicated. This is getting way too complicated. It's not worth implementing like this right now. We don't know what we want. Okay, I recommend that we just don't implement this right now. We only put it in the
Okay. Yeah, some of these are very easy to implement in C++ code and very hard to implement in symbolic code.
Well, then just do them there and give an error message for
Right.
now. Okay.
Well, actually, that's tricky because I have to go into the evolution object.
What do you mean?
Well, it just means sometimes evolution objects you would get would be incomplete.
So fine. So if you ask for the property, then it gives a message. Okay?
Yeah, I guess it's fine.
Yeah. Okay, the event ordering function we need to worry about, but I think we should get all this other stuff done first. Should we just look at since we've just been doing this, right? Possible properties include final state. All right, so the properties include all these properties, right? Am I making sense? They include all these properties and others.
Yes, yes. And all the others should have arguments, otherwise we could just as well include them there.
Right. And that's stupid, and we're not going to put it in here.
It actually does work, but yeah.
Okay.
Well, it's easier to make it work.
Just saying. Yes, I understand that.
Sure.
Okay. So the first thing here is generation count. Right? That's the very first thing. Is the total number of generations. Right?
Well,
so
that should exist in Wolfram model too.
No, it shouldn't.
Why?
Because you just told it that.
Well, what if we told it max vertices?
You know what? Let's not do that. We'll not document it there, okay? It's just too complicated. Let's document it in the Wolfram model evolution object. It can work in the other case.
Okay.
Okay, because it's kind of hard to understand why you would put it in there. Okay, so generation count. The number of complete generations in the evolution. Correct?
Complete generations.
Yes, that's what we want. The number of complete generations. That's the number of the list of states for each complete generation. It's going to be the length of the states list. Right?
Yeah, I guess. Yeah, it's not what it's doing now, but I agree. It's probably what it should do.
Okay, so the next thing is events count.
Well, that means if for random evolution, it would very frequently be 0.
Fine. By the way, here we want events count. Oh, we have that, generation events count, but we want the list of all events during the evolution, but we actually also want events count here, which is the total number of events during the evolution, correct?
So why would we have events count but not generations count?
Because most of the time you're going to be requesting a number of generations. That's why.
Why?
Because that's what the freaking argument to the function is. It's not perfectly consistent. Let's do it this way. Really, it's the right thing. We'll I mean, if it turns out it's stupid, we'll change it, okay? But I think it's not stupid. I think it's less confusing to have fewer things there. And it's very confusing when you see something which you think is the input showing up as the output. Okay, now you're saying that we need some additional properties here, right? Correct?
Yes.
Okay, so those additional properties are match list, matches list, matches.
Yes, just matches. Well, no, it could be match. Let's see.
I think
It's matches after a particular event.
Should we call it event matches? And then it's event matches arrow, and then we have to label an event.
Well, it's not an arrow, it's just a second argument for the evolution object.
How the hell are we going to represent that here?
The evolution object just takes two arguments. It's documented above already. What do you mean after? It's not after, it's the argument for the property.
Okay.
It can be anything.
Gives
like for the case of causal graph, for example, it can be any graph options.
Well, that's opts here. That's different. That's opts.
Okay.
I don't like this. I don't like this. I think we should package it in because we can imagine multiple event matches, you see, with multiple things here.
Actually, I'm not sure if multiple things work for evolution object.
Well, I don't like this. I don't like having the meaning of that depend on which property you're talking about here. What are the cases? What are the different cases here? Event matches.
No, that would take just event index.
It's something like that. I recommend we don't document this case. Okay, I recommend we don't document that case where it's a property and a variable. We can make that work if you want, but let's not document it for now.
I mean, we need to choose one. I don't think we should have both. If you're going to specify
all right, fine. Let's choose this one.
With rules, we should do it.
Let's not.
This way.
Okay, we'll do the T like this, and otherwise it's a property. I'm not totally thrilled with this, but I think it's better than other things. And we can't do it with a list because otherwise it's ambiguous between this case. I need a piece of food.
Do we actually need this case? Because
case?
In case of evolution object, we don't gain anything but specifying list there instead of just mapping over the list.
It's convenient. We will want it. It is convenient. and it will be expected based on the other one. I think we're going to need to decorate this more elaborately. I think this is only the beginning of a quite complicated syntax of possible extractors here. I'm not thrilled with this extractor, but I think it's better than nothing.
Okay.
Okay, is there anything else we need here? We need that. We need rules. Let's put them at the very end. You know, we need something else. We need initial condition. Since we've got it, should we do that, or should we say 0?
I think 0 is fine. There's 0, there is -1.
What's -1?
I don't think we need strings. Well, it's final state.
I didn't know that. Okay, let's list that here. Oh, God. It drives me crazy.
Well, it's obviously not just -1, it's minus anything.
I know that. I know that.
Well, I mean, I could have been lazy and just implemented -1.
The state at generation t. Okay, great. Okay, it's very good. All right. We got a plan here. If you could get these basic things that I need to do these searches up quickly, that would be really, really, really good. Because I'd really like to rerun a bunch of these things tonight.
Which things specifically? I think there are at least 2 things minimum.
Okay, let me show you specifically. Specifically, these at least max vertices, max edges. Okay, max, generations, vertices, edges. Okay, that's one thing. That's actually the main thing I need. And then I'll pick out.
Yes, but you also want states list to return complete generations.
I do, but aren't you going to? Well, yes, that's the only other thing, right?
Which, yeah.
Those are the most critical things. Yes. Okay. That would be.
Well, I'm not sure I can implement both of them tonight, given that it's 10 p.m. already.
Where's it temp? Where are you?
In Massachusetts.
What are you doing in Massachusetts? You are delocalized.
What do you mean? I moved here after the conference. I think I told you before.
No, you didn't tell me. I thought you were on the
I
west.
definitely did tell you.
You
We were
mentioned it.
talking, I was outside at some point.
Yeah, you mentioned it. I had
Talked
no
about it.
idea. Okay, so you're like just around the corner. Okay. Where in Massachusetts are you? Just out of curiosity.
Mattapan,
I don't know where that is.
Mattapan, which is south end of the Red Line.
Wow. Okay, cool. Well, welcome to the same state that I'm in, and not in the states list sense. The, I had no idea. Okay, cool. Boy, when we want to celebrate some exciting universe, we could actually meet in person, maybe. It's well, what could you implement here? Can you get? Look, I don't care about the complete. If you can just get it to limit. No, it's not going to look. If states list gives me complete generations, I just drop the last states list for now. I just have to have something that I can generate. Look, why don't you see what you can do and let me know.
If you drop the last one and
Yes.
you don't ask for generations, you ask for ages and so on, that would almost always be correct.
Okay, fine. When would it not be correct?
Well, if you happen to guess exact number of vertices in a given generation. Yeah, actually, in that case, it would be very, very, like a lot incorrect because it would give you significantly smaller thing.
If it happened to hit that generation.
Yes.
Well, I can live with that right now. Okay. If you can get, I mean, I really like the states list. See if you can. See if there's a clever way to get the states list. Otherwise, just get that.
Well, there are no need for clever way. Just I need to keep track of that in both implementations and put it in the evolution object somewhere.
Okay.
It's essentially just one flag in the evolution object, which says where the final thing is, a complete state or not.
Fine. All right, look, the most important thing is to get something here because I really, really, really want to rerun these things tonight because, Jeremy is waiting for that. Sushma is waiting for that. A bunch of people are waiting for these things to get rerun. Okay? Does that make sense? So I want to rerun them correctly. So why don't you do what you can, and let me know I will have to wrap up by, gosh, we're on the same time zone. It's so unusual. I'm working with people on the same time zone. I will be wrapping up by, I will start to wrap up at midnight. So whatever you can get by like 11:30 or something would be wonderful. Makes sense? Makes more sense for you to go.
I'm really not sure I can do a lot, but
well, okay.
Maybe I can just make experimental branch for you, which would make some things work for the most part.
Okay. All right. Okay.
That would be feasible.
Okay, fine. Do it. Quick question. How are you at? Where are you at with the other things? I really thought how could I have thought that you were in, for the last multiple weeks, I thought you were on the West Coast, which is why I was like not calling you earlier in the day and things like that. Whatever, I'm confused. Doesn't matter. Never mind.
Okay, so the brains are, the slow version that only works for rules is almost done, apart from it doesn't work for rule plot, it crashes as rule plot, and I'm waiting for the new build tomorrow.
Okay.
Where it's fixed.
Okay, good. And that new build also seems to have the front end scrolling bug fixed, so it's a usable build for us.
Do you know if it has missing auto-completion bug fixed, which was introduced recently?
It was being discussed today, so depending on exactly when the build happened, I have high hopes that it's been fixed.
Okay.
All right. All right, let's wrap up. I'm going to go do a few more searches here. I would really love to have this code, but I can do searches without this code. I'm going to actually write the thing that does. I'm going to write it assuming that I'm going to have all this stuff of yours with max events and so on. I'm going to just write it getting ready for that. Okay.
Okay.
Good. All right. Okay. Well, and I will write it assuming that I'm going to have all these various features, and that the renaming will happen of these things like generation counts and things like this. Okay.
Wait, you want me to also rename it today? In hour and in 20 minutes?
No. Okay. All right. So it's okay. Look. So basically, it's going to fail. I'm not going to be able to get this for these guys by tomorrow.
Okay.
I can rerun it with the old code. All right. I'll look. Get what you can. I'll run it with whatever I have. I'm going to write code that assumes this, that hopefully tomorrow I can actually be able to run. Okay. And if necessary, if you don't have the stuff tonight, I will rerun these things overnight with the old code. Okay. Which will at least generate it in the right format for these guys to work with. Make sense?
Okay. So you want experimental code or you want it implemented?
Okay, look, if you can't get it implemented, don't knock yourself out. We'll just punt, okay? I will write.
No, I need to decide right now if I'm going to either implement it or to make it completely experimental. It's completely different things I need to do.
Implement it, okay? And let's get it tomorrow, okay? Implement it, and I'm going to write code now because I remember how this works now. I'm going to write code that will not run today, but will hopefully run tomorrow, okay? That is the correct version of this. Then I will work on, then I'm going to have, existing code that I already have that will run today using the old version of everything that will generate the stuff that is needed for Jeremy and Sushma to make further progress. Make sense?
Okay.
Excellent. All right. This will be good. I think we've now nailed down everything we need for this. So, and then we can do some big searches tomorrow, I hope. I'm really hoping by the weekend to be finished on this round of searches. Okay. All right. I'll leave you alone. Thank you very much. All good. Okay. See you. Let me know what please do let me know what you do happen to, if you pull a rabbit out of a hat, let me see it.
Okay, sure.
Don't take that too literally. I have no idea with you. Okay. All right. Okay. See you later then.
Okay. See you.
Okay. Bye.
Bye.